Hello, good afternoon, guys. Am I audible? My screen is visible. Am I audible? Can we start lecture?
Yes, sir.
Yeah. Okay. So in the last lecture we have started with the virtual memory management. Okay. So in the virtual memory, it is a one of the management scheme in which we are dividing RAM into the page frame and dividing the process into the pages. Definitely, that process is present in the virtual memory. One more thing, that is the page table, which is maintaining by the operating system to map the page frame and pages present in the system. So because of this page table, the blocks need not to be contiguous in the page frame. Earlier we can see that here the process one, it is divided into the pages, and that pages can be loaded into the main memory. So when the concept of page table is introduced, so page table, it stores the mapping between the page frame and pages. So if you load page in any part of the uh, main memory, then that reference we can store in the page table, and through that page table you can access that part of memory. So because of the page table, the blocks need not to be in a contiguous page frame. Okay, memory is not required in a contiguous manner. Any page frame, any page you can store at any page frame. There is no issue because mapping is available in the page table. So every time a memory location is accessed, the processor looks into the page table to identify the corresponding page frame number. And once it got it from there, it can directly access to that page number, page frame. Okay, so this is the picture in which the blocks of process one, or the pages of the process one, is stored in the different blocks of frame in RAM. So you can see the first page is stored at 14th frame, and similarly the second page, that is page 2, is present in uh, second frame, and third page is stored in third page. Mapping is given here. So the third page is stored at the 13th frame, and likewise all other mapping is provided. So based on this mapping, by using this page table, the processor can access the page from any block of frame in a main memory. Now similarly, if there are more than one process present in the system, then in that case also, the blocks of several processes can share pages in RAM simultaneously. Okay, at the same time, you can load the pages from this in RAM. And definitely to access these pages from the RAM, we need a page table. So whenever the process is start executing, operating system creates a process page table with respect to that process. So for every process, there is a page table, and in that page table, the respective mapping is provided. So in the process 2, you can see that the process 2 is divided into the 4 pages, and these pages is stored in the different frame, and this frame and pages mapped in the process page table of P2. So here the first block or the first page of the process 2 is stored in the 10th frame. This is the 10th frame where the first page of process 2 is stored. And similarly, process 3 having also 4 pages, or it is divided into the 4 pages, and these pages are stored in the different location of the RAM, different frame in the RAM, and that frame mapping is provided at respective page table. Now, the question is that do we really need to load all the blocks into memory before the process starts its execution? The question is that whether all the process, whole process, or all the pages of the process, is it required to load all these pages into the main memory? Because when the execution of the process done, it may happen that some part of the process is very rarely used, or some part is not at all used during the execution. So when the part is not used during the execution, then why we need to put that part in the main memory? ओके, जर सपोज त्या प्रोसेसचा काही पार्ट एक्झिक्यूट होत नसेल, तर तो पार्ट रॅम मध्ये स्टोअर करायला काही पॉइंट आहे का? Definitely not. If it is not used, it should not be loaded, because that space can be used for other purpose. So that space should not be loaded into the main memory. Okay, am I audible? Okay, so so it is really not expected that all the blocks of the process should be loaded into the main memory. If the block is not used, then definitely it should not be loaded into the main memory, so that that part can be used by other process, and the speed of the process can be increased. So by using by taking the advantage of this uh, by taking the advantage of this, the virtual memory use another concept is called the demand paging. So in the demand paging, what happened? The pages are loaded into the memory if there is a demand of that page. If the page is really need, or if the page is really accessed, if it is needed for the execution, then only that page should be loaded into the memory. So if the page is demanded, then only that page should be loaded into the main memory. So that is called as the demand paging. So on the demand, the page is loaded into the memory. Unless and until demand is not confirmed, the page is not loaded into the main memory. So in the demand paging, what is happened? The swap space is created on the disk from where the blocks can be transferred to that swap space and can be taken from that swap space. If suppose the blocks need to be removed from the main memory, then it will be moved into the swap space. And suppose the blocks or the pages is required in the RAM, then that pages can be swapped in from the swap space. So one swap space is created in on the hard disk, and the swap in and swap out process can be executed from that swap space. So pages are loaded from the disk to RAM only when it is needed. So in the demand paging, when the page will get loaded, if the page is required, then only needed, then only it will be loaded into the RAM. So the presence of the pages is indicated by present bit, or we can call it as the valid bit. Both are same. Present bit or valid bit, it is used to represent whether the block is present in the RAM or not, in the main memory or not, in the physical memory or not. So for that purpose, present bit is used. If the present bit is 1, that means the block is present in the main memory. If the present bit is 0, that indicates that the block is not present in the main memory. Then in that case, the operating system is triggered, and it will load that page from the swap space into the main memory and update the page table with uh, allocation, that is page frame number, and modifying the present bit as 1. Okay, if the present bit is 0, that means the page is not present, and if it is required, then the OS will load that page from swap space into the main memory, and address of that main memory will be updated in the page table present bit, and then it can be accessed. So same is here. If the page is accessed that is not present in RAM, the processor issues a page fault interrupt. Okay, that is called as the page fault interrupt. So page fault means if the page is not present in the memory, then interrupt is triggered. That interrupt is called as the page fault interrupt. Okay, so page fault interrupt, it is created when page is not present in the RAM, and because of this interrupt, it triggers the OS to load the page into the RAM and mark the present bit to 1. It will load the page into the RAM. It will store the page frame number into the page table, as well as it will update the present bit from 0 to 1, and this one indicates that the page is now present in the main memory. So that is called as the demand paging. And suppose there is no space for the pages. If there is no page frame free for a new block to be loaded, then in that case, the OS should take a decision to remove one of the block from the RAM. ओके, सपोज तुम्हाला पेज लोड करायचंय, पण ते पेज लोड करायला रॅम मध्ये फ्रेम फ्री नसेल. ओके, सगळ्या फ्रेम मध्ये कुठली ना कुठली प्रोसेस समजा स्टोर असेल, कुठलीही फ्रेम तुम्हाला अवेलेबल नसेल, तर त्या केसमध्ये ओएस ला एखादी फ्रेम फ्री करावी लागते. नथिंग बट त्या फ्रेम मध्ये जे काही पेज स्टोर केले ते पेज रॅम मधून रिमूव्ह करावं लागतं, त्या फ्रेम मधून रिमूव्ह करावं लागतं. And to remove the page, the OS is used a policy is called as the page replacement policy. So what is the page replacement policy? To page from the memory. Okay, पेज तुम्हाला रिमूव्ह करायचं तर कोणतं तरी बेस पाहिजे ना, की कोणतं पेज तुम्हाला रिमूव्ह करायचंय. So for that purpose, there should be a policy to replace the page from the main. So OS used a replacement policy to remove the page from the memory. So there are some different replacement policies that are present. So among that, the most popular, there are 3 policies are there. The first policy is first in first out policy. Second policy is least recently used policy, and third policy is the least frequently used. Okay, definitely all this policy we are going to study in detail So I will not explain at this moment here. So this page replacement is performed so that a new block can be allocated in the main memory. Sometimes it may happen that when the block is removed, then it may happen that some of the changes is done in that block. ओके, सपोज डेफिनेटली जर पेज तुमचं मेन मेमरीमध्ये आहे तर त्या केसमध्ये डेफिनेटली देर आर सम चेंजेस आर गोइंग ऑन. जर सपोज एखादं पेज फ्रेम मधला डेटा मॉडिफाय झाला असेल आणि तोच डेटा जर तुम्हाला स्पेस मधून त्या फ्रेम मधून रिमूव्ह करायचा असेल तर डेफिनेटली दॅट मॉडिफिकेशन शुड बी रिफ्लेक्टेड परमनंटली. कारण की रॅम मध्ये ह्याचा अर्थ ते मॉडिफिकेशन टेम्पररी आहेत आणि तुम्हाला रिमूव्ह करताना ते मॉडिफिकेशन permanent करावं लागतील. So for that purpose you should write back whatever the changes that is you have maintained in the RAM, you have to write back that into the swap space. जेवढं काही मॉडिफिकेशन झालं असेल ते मॉडिफिकेशन तुम्हाला स्वॅप स्पेस मध्ये पण राईट करावं लागतं आणि ते राईट केल्यानंतर देन यू कॅन रिमूव्ह द पेजेस. Otherwise that data will not be stored, and if you remove that page, data will automatically gone. Okay, so to avoid this, it will first check whether the changes or whether the modification is done in the pages or not. Okay, so here in this case you can see that to access a page, suppose the present bit is 0, that means the page is not available. So in that case the OS needs to bring that page from the spare space into the RAM, but since there is a no block available, so it will implement one of the place replacement policy and it will remove the block. So for example, suppose it has removed the block 1 and instead of that it is loading the block 3. Okay, so whenever it is removing that block, then first it will check the whether there is a modification is done or not. So to indicate that modification, one more bit that we are using is called as the dirty bit. So why the dirty bit we are using? So dirty bit, it indicates that if the page is needs to be returned back to the disk or not. Nothing but if any modification is done in the page or not. If the modification is done, then definitely you need to write that modification to the disk. So your dirty bit, it indicates that if the page is needs to be written back to the disk or not. If the dirty bit is 1, that indicates that the page needs to be written back to the disk. That means the dirty bit 1 indicates that the page is modified and you need to reflect that modified changes to the disk. So that's why you need to write back that page to the disk when the dirty bit is 1. If the dirty bit is 0, that means not any modification is done on the pages, so you can directly remove that page. Okay, so dirty bit 0, directly you can remove the page. If the dirty bit is 1, you have to write back that page to the disk space, and then you can remove the page from the menu. Understood? One more bit that is required is the protection bit. Now, why protection bit it is used? So protection bit, it is it determines that if the page is it determines the protection rights. Okay, it protects the page by providing some restriction using the protection bit. So based on the protection bit, you can determine if the page is executable, read only, or accessible by a user process. So this restriction is done or provided by using the protection bit. So in the page table, total 5 fields we have seen. First field, it is the block number. block number. Second, it is the page frame number, where that page is stored, that page frame number. Third field, it is the present bit or valid bit. Fourth field, it is the dirty bit, which indicate that whether page is modified or whether the page should be written back to the disk. And the fifth bit is the protection bit, which determine if the page is executable, read-only, or accessible by a user process. So understand clear what is the demand paging. समजले का सगळं? What is the demand paging? Okay, now we will see virtual address space of a process. So when any process is started execution, how the process get allocated, how it is used, the virtual address space from the virtual memory. Okay, so for that purpose, suppose one example, one program you can say take as an example. Suppose the program is the printing the hello world on the screen. Simple program is there. When it will get compiled, it will generate executable file that is present on the disk. So that executable file, which is the a.out file, which is divided into the four parts. First is the text part, which contains all the instruction, that is binary, which is present in the form of binary form. Second part is the data, where the data with respect to that program is stored. Third is the heap, and fourth is the stack part. Okay, so whenever the process it is loaded into the virtual memory, then this a.out file it will generate the continuous virtual addresses. Okay, it is using a continuous virtual addresses, and these addresses are seen by the processor. So processor it always seen the process as a contiguous manner. Okay, word processor it is not seen the process as the non-contiguous manner. कारण की ऍड्रेस जे काही प्रोसेसरला मिळत आहेत ते सगळे ऍड्रेस कुठले आहेत? व्हर्च्युअल ऍड्रेस. आणि व्हर्च्युअल स्पेस मध्ये प्रोसेस सगळं व्हर्च्युअल कंटिन्युअस ऍड्रेस यूज करते. So for here in this example, you can see the process is start from the 0 and it is end at the max size. It is end at the max size. So whatever the address is that is used in the process, that should be present in between 0 to max size. तेवढ्यामध्येच ते जे ऍड्रेस जनरेट व्हायला पाहिजे. So when the process, when the compiler compiles the program and generate this a.out file, then this a.out file it contains information about how to create the virtual address space. That all information is present in the a.out file. And when the OS is executing this file, then OS is using all this information that is produced by the compiler. So when the address is when the address is received the processor, or when the processor want to execute any instruction, then it will generate the, or it will give the virtual addresses, because all the processors have the virtual address only. So definitely this virtual address it should be present in between the 0 and max size. जो काही ऍड्रेस प्रोसेसर जनरेट करेल तो ऍड्रेस हा 0 to max size ऍड्रेस मधलाच असला पाहिजे. So this all care regarding the mapping is taken by the memory management unit, which is the another hardware component present in the processor, which takes care of mapping between the virtual memory and main memory. तर व्हर्च्युअल मेमरी आणि मेन मेमरी या दोन्ही मधलं जे काही मॅपिंग असेल ते सगळं मॅपिंग MMU हँडल करतं. मेमरी मॅनेजमेंट युनिट, which is the hardware component, and that component is present in the processor. So processor, MMU, both are the hardware component, whereas the operating system, it is the software component. Okay, so MMU, it map this virtual address to the physical address and access the corresponding physical address present in the RAM. Okay, definitely for that purpose, MMU use the page table. MMU use the page table. So, and page table, along with that page table, one pointer, one register is required, that is the page table pointer register, or also we can call it as the page table base register, जो की पेज टेबलची स्टार्टिंग लोकेशन तुम्हाला प्रोव्हाइड करतो. Okay, that means whenever processor generates any virtual address, then memory management unit will take that memory address, divide into two parts. Here you can say virtual address divided into the two parts. The first part is the page number, also called as the table index. So this page number, and second part is the page offset or displacement. So this virtual address is divided into the two parts. First part is the page number and second part is the offset. And also it is taking the page table base register, which is pointing to the first location of page table. So it will go to the page table, it will search this table index or the page number in the page table. If that number is present, then it will search the page frame number for that respective block. So it is access that page number as 1, and by taking this 1, by accessing this 1, it combines this page frame with the page offset. It combines the page frame with the page offset, and now this combined address is called as the physical address. This is called as the physical address, and this physical address is pointing to the main memory location. Main memory location. So this mapping is done by memory management unit. So main function काय मेमरी मॅनेजमेंटचं, की जेव्हा पण प्रोसेसर ऍड्रेस जनरेट करेल, जेव्हा प्रोसेसर एखादा ऍड्रेस जनरेट करेल, ऍड्रेस जनरेट ऍक्च्युअली प्रोसेसर नाही करत, प्रोसेसर करतो रिसीव्ह होतो. प्रोसेसरकडे एखादी इन्स्ट्रक्शन येते, इन्स्ट्रक्शन तो एक्झिक्यूट करतो, एक्झिक्यूट केल्यानंतर त्यामध्ये ऍड्रेस स्पेसिफाय असतो आणि तो ऍड्रेस असतो तुमचा व्हर्च्युअल ऍड्रेस. व्हर्च्युअल ऍड्रेस प्रोसेसरला त्यामध्ये काही समजत नाही, मग त्यासाठी प्रोसेसर काय करतो, तो ऍड्रेस हँडओव्हर करतो मेमरी मॅनेजमेंट युनिटला. मेमरी मॅनेजमेंट कडे ऑलरेडी तुमचा पेज टेबलचा बेस पॉइंटर आहे. MMU कडे ऑलरेडी पेज टेबलचा बेस पॉइंटर आहे. मग कोणताही व्हर्च्युअल ऍड्रेस तो प्रोसेसर कडून घेतो. प्रोसेसर कडून ऍड्रेस आला, दोन पार्ट मध्ये डिवाइड करतो. पहिला पार्ट पेज नंबर, दुसरा पार्ट ऑफसेट. पेज नंबर घेतो, पेज टेबलला जाईल, तिथं तो सगळं सर्च करेल की तो पेज नंबर तिथं अवेलेबल आहे का नाही. जर तिथं अवेलेबल असेल तर त्या पेज नंबरचा रेस्पेक्टिव्ह पेज फ्रेम नंबर तो ऍक्सेस करेल आणि तो पेज फ्रेम नंबर कंबाईन करेल तुमच्या ऑफसेट सोबत, and then it is form a physical address. Okay, so this whole task, this whole mapping is done by the memory management unit. Okay, understand? समजलंय का? So can we take one of example to understand this? Okay, well, at least one of the guys there who is listening all these things. Okay, now suppose you are using a 32-bit system. You have Windows 32 OS. आता 64 बिटच्या पण आहेत. आपण कन्सिडर करूया की currently we are using a 32-bit operating system. So in that 32 operating system, definitely 32-bit address will be generated. Okay, now normally पेजची साईज असते 4 KB ची. इंटेलचे जे काही सध्याला इंटेलचे जे काही प्रोसेसर आहेत ते प्रोसेसर जनरली 4 KB पेज साईज किंवा फ्रेम साईज यूज करतात. ओके, आता लेटेस्ट जे आलेत ते इंटेलचे त्या इंटेलच्या प्रोसेसरमध्ये पेजेसची साईज ही 4 KB पेक्षा पण जास्त आहे. ओके, पण आपण जनरल यूज करूया की 4 KB ची साईज पेजची आहे. सो इफ द साईज ऑफ द पेज is 4 KB, then definitely 12 bits need to be required to access the location of that page. Okay, आता हे कसं डिसाइड केलं की 4 KB ला 12 बिट लागेल म्हणून? Can anybody give me explanation? पेज साईज जर तुमची 4 KB असेल तर त्याला 12 बिट्स लागतील. हाऊ कॅन यू आयडेंटिफाय? जर समजा उद्या पेजची साईज 8 बिट असेल, सॉरी 8 KB असेल, तर त्या केसमध्ये किती बिट लागतील? ओके, जोपर्यंत तुम्हाला हे बेसिक क्लिअर होत नाही ना तोपर्यंत तुम्ही गेटचे क्वेश्चन कधी सॉल्व्ह करू शकणार नाही. कारण गेटमध्ये ह्या टाईपचे क्वेश्चन बरेचसे येतात. ओके, ऍक्च्युली हा कन्सेप्ट तुम्हाला परत आर्किटेक्चर मध्ये पण सीओ मध्ये पण यूज होतो. सो हाऊ कॅन यू आयडेंटिफाय? ओके, कन्सिडर दॅट पेज साईज तुमची 4 KB आहे. ह्याचा अर्थ काय की तुम्ही तिथं 4 KB चा डेटा स्टोअर करू शकता. किती? 4 KB चा. ओके, सपोज. ओके, very good. Prashant Jalgiri, excellent. He has given the answer 13 bits. So for 8 KB, it required 13 bits. So how it is calculated? So I say that suppose समजा पेज साईज तुमची 4 KB ची आहे. पेज साईज किती आहे? 4 KB ची. ओके, एक्झाम्पल घ्या की पेज साईज तुमची आहे 1 बाईट. म्हणजे एका पेज मध्ये तुम्ही 1 बाईट डेटा फक्त स्टोअर करू शकता. 1 बाईट मीन्स किती? 8 बीट. सो दॅट यू कॅन स्टोअर 8 बीट ओनली. यू कॅन स्टोअर 8 बीट. सो म्हणजे एका पेज मध्ये 1 बाईट डेटा स्टोअर करू शकता म्हणजे तुम्ही 8 बीट स्टोअर करू शकता. मग त्या 8 बीटला ऍक्सेस करायला 8 बीटला तुम्हाला सेपरेट ऍड्रेस द्यावा लागेल. प्रत्येक बीटला एक ऍड्रेस डिफरंट. म्हणजे 8 बीटला किती ऍड्रेस झाले? 8 ऍड्रेस. आणि ते 8 ऍड्रेस साठी किती बीट लागतील? 8 ऍड्रेस साठी किती बीट लागतील? 3 बीट. जर 4 ऍड्रेस असतील, 4 ऍड्रेस साठी तुम्ही 00011011 4 ऍड्रेस तुम्ही देऊ शकता. 2च ऍड्रेस असतील, 2च बीट स्टोअर केले, 2 ऍड्रेस. मग त्या केसमध्ये फक्त 0 आणि 1 एकच बीट सफिशियंट आहे. एकच बीट सफिशियंट आहे 2 ऍड्रेस रेफर करायला. जर 4 बीट असतील तर त्या केसमध्ये 4 ऍड्रेस लागतील. 4 ऍड्रेस साठी 2 बीट 00011011. Are you getting? Are you getting or not? So similarly, when the page size is 4 KB, 4 KB means 2^12 bits. So when there is a 2^12 bits, you require 12 bit to access all the address within that pages. To access all the address within that pages. म्हणजे पेजेस मधले मला सगळे ऍड्रेस जर ऍक्सेस करत असेल तर त्यासाठी मला 12 बीट रिक्वायर्ड आहे. Okay, so when there is a page size is of 4 KB, then among the address of 32 bits, 12 bytes should be reserved for that page. Okay, 32 बीट पैकी 12 बीट मला ते पेज मधले आतले ऍड्रेस ऍक्सेस करण्यासाठी रिक्वायर्ड आहेत. म्हणजे मला 32 बीट मधले 12 बीट ह्या पेज साठी यूज करावे लागतील. कधी जर पेज साईज 12 KB ची असेल. पेज साईज म्हणजे फ्रेम साईज, बोथ आर इक्वल. सो पेज साईज म्हणा किंवा फ्रेम साईज म्हणा. इफ दॅट इज 4 KB, then in that case you require 12 bits. You require 12 bits. So out of 32 bits, 12 bits gone for the offset. 12 bits gone for the offset. So how many bits are remaining? How many bits are remaining? 20 bits. Out of 32 bits, 12 bits, it is reserved for page offset. So these 20 bits, these are now available for page referencing. पेज रेफरन्स करायला, पेजला पॉइंट आउट करायला तुमच्याकडे 20 बिट्स आहेत. किती आहेत? 20 बिट्स. सो युजिंग दॅट 20 बिट्स, हाऊ मेनी मॅक्झिमम नंबर ऑफ पेजेस कॅन बी क्रिएटेड? कॅन एनीबडी आन्सर मी? Using the 20 bits, maximum how many pages can be created in the main memory? Can anybody answer? ठीक आहे, माझं एक पेज आहे 4 KBचं. दॅट्स फाईन, दॅट्स फाईन. मग आता ते एक पेज मला ऍक्सेस करायला एकच बिट लागेल, एकच पेज. डेफिनेटली त्या पेजमध्ये 4 KBचा डेटा आहे, दॅट्स फाईन. पण त्या एक पेजला ऍक्सेस करायला मला एक इंडेक्स, दॅट इज 0, दॅट इज सफिशियंट. जर सपोज त्याच्या 2 पेजेस असतील, 4 KBचे मी 2 पेजेस तयार केले, मग त्यांना मला इंडेक्स करायला 0 आणि 1. So using 1 bit, I can indexing 2 pages. Using 1 bit, I can indexing 2 pages. Now I have 20 bits. So using that 20 bits, maximum how many pages I can refer? It is 2 raised to 20. Maximum 2 raised to 20 pages I can refer. I can refer 2 raised to 20 pages. Are you getting? So, okay. So 12 bits, 20 bits you are using for the 20 bits you are using for page referencing. Okay, now since the virtual address is of 32 bits, so maximum process size, it is 4 GB. That is 2 raised to 30. Maximum addressing that can be you can done using 32 bits is the 2 raised to 32. So the process size, it is maximum 4 GB. Process size should be maximum 4 GB. If suppose you are using 64-bit system, then in that case maximum 2 raised to 64 address can be generated, so that the maximum process size can be 2 raised to 64. It can be 2 raised to 64. So in that case, the maximum process it may be 2 raised to 64. Okay. So here, if each frame size is of 4 KB, then 12 bits are required to address a page, and so that the offset is 12 bits and index is 20 bits. Okay, so maximum number of entries or the maximum entries in the page table that you can do, it is the 2:20. Okay, maximum pages are 2:20 असतील तर त्या केसमध्ये definitely the maximum address that can be generated, it may be a 2:20. So the maximum entries that you can done in the page table, it is a 2:20. To 2:20 pages you can generate it, and for that 2:20 pages you can make the entries in the table which is of the size 2:20, nothing but around 4 MB. This is around 4 MB. Okay, so this 4 MB now definitely. Now this 4 MB size is of the page table size. 4 MB size जी आहे ती तुमची पेज टेबलची साईज आहे. But we have the page of size 4 KB only. आपल्याकडे जो पेज आहे त्या पेजची साईज 4 KB ची आहे आणि आपण त्या 4 KB पेजच्या मेंटेनन्ससाठी जो पेज टेबल यूज करतोय तो पेज टेबल 4 MB चा आहे, विच इज नॉट ऍक्सेप्टेबल. ओके, कारण की तुम्हाला जर 4 MB ची जर ती पेज टेबल मेंटेन करायचं असेल, डेफिनेटली पेज टेबल ज्यावेळेस तुम्ही क्रिएट करता, इट रिक्वायर अ कंटिन्युअस मेमरी. It require contiguous memory. So the continuous memory that is required, it is the 4 MB, which is the very large. So for that purpose we are using two level paging. For that purpose we are using two level paging. When the size of the page become very large. So when it become large, in that case we are using a two level paging. Okay, which I have explained in the last lecture. Okay, so in the two level paging, again we have the three fields. One is the directory, second is the table, and third is the offset. So directory page field which maintains the pages for which creates one directory, and one more pointer that is required, that is PDPR pointer, which is the page directory pointer register pointing to the first location of that page table. Okay, from that page table you will get the inner page table reference. You can see here, this is the outer page table. From that you can get the inner page table reference. Then you can go to the inner page table. From that you can get a page frame number, and then you can access the actual physical frame number, and from that you can generate the physical address. This is the two level page translation. Okay, this is already we have covered in the last lecture. Okay, now I have one question. Offset is 12 bits. Here table is 10 bits. Table is using the 10 bits. ह्या केसमध्ये त्या पेजची साईज किती असेल? जर तुम्ही 10 बिट्स यूज करत असाल टेबलसाठी, म्हणजे पेजची साईज किती असेल? Can anybody answer? Very good. It will be a 1 KB. That means it is 1 KB. See, जर तुम्हाला हे कळलं ना, you can easily solve the gate question. गेट साठी हाच कन्सेप्ट सगळ्यात महत्वाचा. हे कळलं तर तुम्ही इझिली गेट क्वेश्चन सॉल्व्ह करू शकता. Okay, very good. So number of pages table is the 1024. So total size of page table, it is 4, sorry, it is 4 MB, but it is not contiguous. Okay, now that page table, it is not contiguous. Okay, now we will see one real-time example regarding the demand paging or working of your virtual memory. What the sequence of steps that you need to take when you are executing your program in the virtual memory. So again, I will take the example of simple program that is printing hello world. ओके, हॅलो वर्ल्डचा सिंपल प्रोग्राम आहे आणि तो प्रोग्राम सपोज तुम्ही तुमच्या व्हर्च्युअल स्पेस मध्ये व्हर्च्युअल मेमरी मध्ये स्टोर आहे. डेफिनेटली द प्रोग्राम इज कंपाइल्ड अँड प्रेझेंट इन द फॉर्म ऑफ बायनरी. ओके, आपण बाय डिफॉल्ट कन्सिडर करतो की ती फाईल तुमची एक्झिक्युटेबल फाईल आहे. आर यू गेटिंग? and that file is stored on the virtual space, virtual memory. ओके, डेफिनेटली ज्यावेळेस ती a.out फाईल असेल, एक्झिक्युटेबल फाईल असेल, तर ती एक्झिक्युटेबल फाईल 4 सेगमेंटमध्ये 4 सेक्शनमध्ये डिवाइड होईल. फर्स्ट सेक्शन टेक्स्ट, सेकंड सेक्शन डेटा, थर्ड हीप आणि फोर्थ स्टॅक. टेक्स्ट डेटामध्ये ऑल द इन्स्ट्रक्शन, ऑल द binary instruction is present in the text area. डेटा पार्ट मध्ये, डेटा सेक्शन मध्ये जो काही डेटा या प्रोग्राम मध्ये यूज केला असेल, ओके, ह्या केस मध्ये आता डेटा काय आहे, हॅलो वर्ल्ड ही एक स्ट्रिंग आहे, तर ती स्ट्रिंग तुमची डेटा एरिया मध्ये स्टोर असेल. हीप एरिया डायनॅमिकली ज्यावेळेस तुम्हाला मेमरी अलोकेट करायची असेल तर त्या केसमध्ये आपण हीप एरिया यूज करतो. फॉर एक्झाम्पल, जावामध्ये ज्यावेळेस तुम्ही ऑब्जेक्ट क्रिएट करता, ऑब्जेक्ट क्रिएशन इट इज रन टाइम. सो इन दॅट केस memory will get allocated from the heap area. And stack area, when the function is called, then the stack area is used, as well as the local data using memory from the stack area. Okay, so that is the basic part. Now, when you are using paging concept, then definitely in the virtual memory management scheme you have to divide this whole process into the pages. ओके, म्हणजे ही तुमचं जे काही पूर्ण प्रोसेस आहे ती तुमची पेजेस मध्ये डिवाइड होईल. सो दिस इज वन पेज, दिस इज अनदर पेज. सो दिस black line is defines the boundary for the pages. Okay, that's this black line. It shows how the total process is divided into the pages. Okay, so this is division of the process. Now, when OS start executing this process, then the first task of the OS is creation of the page table. So remember, whenever process start execution of process, whenever OS start execution of the process, first task is the creation of the page table. OS will first create the page table. Definitely that page table will reside in the main memory. And after that, when control come to the main, OS will handle control to the मेन फंक्शन. ओके, जैसे तो मेन ला येईल त्यावेळेस ओएस कंट्रोल ट्रान्सफर करेल मेन कडे. देन when the processor try to execute the first instruction, when OS try to execute the first instruction, then it will try to execute that address. So here it is defined, when the program begins execute, the OS creates page table in RAM. The page table, definitely it is empty. Okay, that is one point. When the page table is created by the OS, At the time, the page table is empty. There is no any entry in the page table. Page table is entry. Also, the RAM may not contain any of the process block. RAM is also not containing any of the process block. Now, to fetch the first instruction, the CPU put, put out the virtual address. To fetch the first instruction, CPU put the virtual address. Now, this virtual address definitely the processor will transfer to the memory management unit. So processor and MMU, these two are hardware component in the memory management scheme, whereas operating system is the software component. So processor pass virtual address to the MMU. Then MMU look up into the page table. Okay, now you can understand when the address is reached at the MMU, it divide into the two parts. First part is the page number, second part is the offset. It will take that page number. As well, MMU already has the page table reference. So it will go to that page table and it will try to find out that page number, whether that corresponding is page is present in the RAM or not. Now for that purpose, definitely it will check the present bit. It will check the present bit. Now it if here definitely the page is not present in our case, so it will generate a page fault, which is the interrupt. It will generate the page fault interrupt, page fault trap interrupt, and this interrupt will trigger the OS to execute. Now, what OS will do when OS trigger, it will first check. Now OS will not directly go to the virtual space. First, it will check whether the page referred is legal or not. If it is legal or not. If the page is legal, it will identify page location on the disk. Then it will identify a page frame that is to be used, whether it is available or not. If it is available, it is okay. If it is not available, then remember it will implement page replacement scheme. So here, since the page frame is available, it will identify whether the page is, it will identify the page frame that is going to be used. It perform write back the exiting page if it is needed. Now when the write back will perform, if the page want to remove, and when the page will remove, if there is no sufficient space. So if page should be removed, then it will perform write back. That is, whatever the changes that is modification is done, that will be returned to the disk. And after that write back, it will remove the page. And then afterwards, it trigger loading of new page from the disk into the RAM. Okay, and after that, it is going to update the page table. मग त्या पेज टेबल मध्ये काय होईल, त्या पेज फ्रेम नंबरची एंट्री होईल आणि प्रेझेंट बीट पण 1 म्हणून सेट होईल. Okay, again I am repeating the process. What happened first? First, OS transfer control to the main function. Then processor try to access the first instruction. Then for that purpose, processor have the virtual address. It will transfer that address to the MMU. MMU, it look up into the page table for that address. Then definitely that page is not present. Page not present, generate page fault interrupt. When the page fault interrupt occur, OS trigger, then OS, it will first check. What it will check? It will check if the page referred is legal or not. If it is correct, then it will identify the page location on the disk. If the page is present on the disk or not, then it will identify page frame to be used. If page frame is available or not. If it is not available, then it will use page replacement algorithm. Then before applying that page replacement, if the page is modified, then perform the write back. After performing write back, remove the page and then trigger for loading new page from the disk into the main memory. And after that, update the page table. So this all scenario is happen when you execute any process using the virtual memory. Is there any doubt? आतापर्यंत जेवढं काही आपण शिकलो ते सगळे कन्सेप्ट तुम्हाला ह्या एक्झाम्पल मध्ये कव्हर झाले. ह्यात कुठं काही प्रॉब्लेम, कुठं काही कन्फ्युजन, यू कॅन आस्क. Is there any confusion? ओके, नो कन्फ्युजन. ओके, 2 मिनिट देतो फक्त एकदा व्यवस्थित रीड करा, व्यवस्थित रीड करा, सो दॅट वी कॅन मूव फॉरवर्ड. ओके, बेटर ऑप्शन, ड्रॉ दिस डायग्राम. हे डायग्राम ड्रॉ करा. आपलं स्टार्टिंग इथून आहे ना. येस, ड्रॉ करा आणि त्यानंतर ही इन्स्ट्रक्शन स्टेप बाय स्टेप लिहून घ्या, सिक्वेन्स ऑफ स्टेप. डू इट फास्ट. आपल्याला पेज रिप्लेसमेंट अल्गोरिदम पण घ्यायचे. ड्रॉ दिस डायग्राम. This diagram is not available in the book. And the next step, to fetch the instruction, CPU puts out virtual address. After that, run down this instruction. Okay, write this step. Finish. So at the end, CPU reissue the instruction and send the same virtual address to the MMU. MMU now computes the physical address, causing the first instruction to be fetched by the CPU, and then the page can be accessed. So likewise, all the respective pages are loaded. Okay, this is the first page get loaded. Then after that, if the second page is, after that, if the second page is needed, then again that page will be loaded into the memory. After that, third page, and so on. As per requirement, the pages will get loaded into the memory. Okay, so that was regarding the sequence of steps using the virtual memory in actual execution. So now we are going to see what are the page replacement policies that is used in the OS. So this page replacement policy, this is important if the memory is full. If the memory is full and one of the page needs to be loaded into the memory, then in that case, one of the page should be selected from the main memory, which is not currently used, and removed from the memory, and in that place load another page for the current execution. So for that purpose, for this page removal, definitely some policies should be there, on which basis the page should be selected for the replacement. That page replacement policies are provided. So we have seen that this page replacement strategy, it is useful when no enough page frames are available to accommodate new process page. So several algorithms are proposed which differs in page fault rate. Okay, this is one more point. Uh, which is important in page replacement. Your page replacement should be in such a way that there should be a minimum page fault. The page replacement, it should be a such a way that there should be a minimum page fault. कारण जेवढे मिनिमम पेज फॉल्ट असेल तेवढं तुम्हाला कमी वेळा डिस्क ऍक्सेस करावी लागेल. मेमरी फॉल्ट जास्त, तुमचं स्पीड कमी होईल. सो the page replacement policy, it should be designed in such a way that the page fault rate should be a minimum. So whatever the page replacement policy that is available, among that the optimal page replacement algorithm is generate least number of page fault. Okay, whatever the page replacement algorithm or page replacement policy we have, okay, we are going to study three policies. First is the first in first out policy, second is the optimal page, and third is the least recently used. So among that, the optimal page replacement algorithm, it is the one which is generating least number of page fault. But actually it is very difficult to implement. So why, that we'll see during the detailed study of that page replacement algorithm. So in normal scenario, page fault reduce with increase in available page frame. If you want to reduce page fault, then what is the solution that you can have? Solution is simple: increase available page frame. Increase available page frame. Page frame भरपूर म्हणजे space जर असेल, definitely you can load more pages and you will get less page fault. That is simple. So simple thing to avoid the page fault is make available more page frame. Okay, so now we are going to study first page replacement algorithm, and that algorithm is the first in first out algorithm. So according to this algorithm, the page which is selected to remove, the page which is going to select to remove is based on the first in first out. म्हणजे जो पेज मेमरी मध्ये फर्स्ट एंट्री होईल तो पेज रिमूव्ह करा. सिंपल. The page which is loaded first, that will be removed first. So this is the first in first out policy. Okay, so we can understand this policy by using one example. Okay, so suppose we have the reference string 701200304230321 and 701. This is the reference string. Okay, so that means 7 is present in the first, 0 is second, 1 is third, and so on. This is the reference string. Now suppose CPU start to execute the program. It will check the data. Since data is not present, page fault occur. OS trigger and OS will load the 7 into the main memory. Okay, this is the size of the page frame is 3. Okay, one more thing, size of the page frame is 3 in this case. So size of the page frame is 3 and the reference string is given, and the first 7 will be loaded. Then it will try for the second string 0. 0 is present in memory or not. It will check. 0 is not present. Again page fault occur. Access the memory. Store into the main memory. Okay, access the disk. Store into the main memory and access it. After that, next reference string is 1. Again, it will check in the page frame. 1 is not available. Generate page fault. Generate page fault and access from disk and load into the main memory. So now page frame is full. Page frame ची साईज 3 आहे आणि तुम्ही तिन्ही स्ट्रिंग स्टोर केले. Okay, now when you are try to load new reference string in the page frame, then you need to remove one of the string. You need to remove one of the string. So since we are applying first in first out, the OS will check which element is first taken into the page frame. So definitely in this case 7 is entered first, so it will remove the 7, and in place of that 2 will be entered. Okay, then next reference string is 0. 0 is already available, so no page fault is there. Okay, now this is the first instance when page fault is not occur. आधीच्या चारही केसमध्ये पेज फॉल्ट अकर झालाय. या केसमध्ये पेज फॉल्ट अकर नाही झाला बिकॉज ऑलरेडी स्ट्रिंग इज प्रेझेंट इन द पेज फ्रेम, सो इट इज डायरेक्टली कॅन ऍक्सेस फ्रॉम द physical address. It is already available. Next string is the 3. 3 is not available. Then for 3, one of the frame should be removed. Then it will check which string is entered first. So among this 201, 0 is entered first, so it will remove 0, and out in place of 0 3 will be loaded. ओके, या केसमध्ये पण पेज फॉल्ट अकर झालाय. या केसमध्ये पेज फॉल्ट अकर झालाय आणि तो 0 ठिकाणी प्लेस होईल. नेक्स्ट स्ट्रिंग कोणते आहे? 0. 0 प्रेझेंट आहे का? प्रेझेंट नाही. सो अगेन जनरेट पेज फॉल्ट. पेज फॉल्ट अकर झाला, स्ट्रिंग लोड करा. त्यासाठी एक पेज रिमूव्ह करावं लागेल. 2, 3, 1 मध्ये पहिल्यांदा कोणतं पेज आले? इट इज 1. सो 1 विल बी रिप्लेस्ड. 1 will be replaced, so content will be 230. Then next string is 4. Next string is 4. 4 is not available. Page fault generate. Among 230, 2 is first. 2 is first available, so 2 will be removed. 430 is present. Then next string is 2, replaced by 3. After that 3, replaced by 0. After that 0, replaced by 4. Then it will access 3. 3 is already present, no page fault. 2, 2 is also present, no page fault. 1, 1 is not present, page fault occur. Then 2 is replaced. 2 is replaced. Then next string is 2. Checking 0, 1, 3 is present in the page frame. No 2 is present. So page fault occur. 2 will be loaded in place of 3. Then it will check for 0. 0 is not present. Sorry, 0 is present. No page fault. 1, 1 is present. No page fault. 7 not present. Page fault occur. 0 remove. 7 replaced. Then 0, 0 is not present, page fault occur. 1 will be removed, 0 will be loaded, and last 1 not present, so again page fault occur and it will be replaced by 1. So total number of page fault 4 plus 5 9 to 11 plus 3 14. Is it 14? No. 4 plus 6 10. It is 15. Total 15 page fault is occur for the reference string of the length. What is the length of reference string? 2, 4, 6, 8, 10, 13, 16, 20. So for the 20 reference string, 15 page fault is occur in FIFO manner, in FIFO page replacement algorithm. काय केले समजले? ओके, शॉर्ट मध्ये परत एकदा रिवाइज करतो. आपण काय करतोय, आपल्याला पेज रिप्लेस करायचंय. मेन मेमरी मध्ये आपल्याला पेज लोड करायला जागा नाहीये. मग त्या केसमध्ये ऑलरेडी अवेलेबल जे पेजेस आहेत त्यातलं एक पेज तुम्हाला रिप्लेस करायचंय. पण कोणते पेज रिप्लेस करायचं त्यासाठी काही अल्गोरिदम आहे. पहिला अल्गोरिदम कोणता आहे? फर्स्ट इन फर्स्ट आउट. जे पेज पहिल्यांदा तुम्ही मेमरीमध्ये लोड केले ते पेज तुम्हाला रिमूव्ह करायचे. दॅट इज सिम्पल थिंग. ह्या केसमध्ये काय केलं आपण? एक रेफरन्स स्ट्रिंग घेतली. रेफरन्स स्ट्रिंग 20 लेंथ त्याची 20 आहे. 20 रेफरन्स स्ट्रिंग आपल्याकडे आहे. मग सुरुवातीला एम्प्टी आहे, सगळ्या पेज फ्रेम एम्प्टी आहे, कुठल्याही त्यामध्ये स्टोअर नाहीये. त्यामुळे पहिले तेच पेज फॉल्ट बाय डिफॉल्ट होते आणि त्यानंतर ते चेक करत जाईल रेस्पेक्टिव्ह स्ट्रिंग त्या पेज फ्रेम मध्ये प्रेझेंट आहे का नाही. पेज मध्ये त्या पेज फ्रेम मध्ये प्रेझेंट नसेल, पेज फॉल्ट जनरेट करेल, डिस्क वरून ते ऍक्सेस करेल आणि पेज फ्रेम मध्ये स्टोअर करेल. दॅट इज सिम्पल थिंग. सो all of you understood or should I repeat? Is it clear to all? Clear to all? No doubt? Okay. Okay, so what is the advantage of this FIFO? So FIFO page replacement algorithm is easy to understand and implement. That is the most advantageous thing regarding the FIFO. It is very easy to understand as well as implementation. But what is the disadvantage? It is not optimal. That is, the solution doesn't lead to a minimum number of page fault. Okay, you have seen that for the 20 reference string, 15 page faults are generated, which is not optimal. And what is the requirement? Our requirement is that there should be a minimum number of page fault. Okay, so for that purpose, we can use another page replacement algorithm, that is the optimal page replacement. So what happened in the optimal page replacement? In this page replacement algorithm, the pages which is not going to be used for the longest amount of time in future, and not future, it is future. In future, these are chosen as victim. What is the concept? The pages which are not going to be used for the longest time in future, these pages are selected for the replacement, selected as a victim. So that is the concept of the optimal page replacement, but it is very difficult to implement because it requires a future knowledge of reference string. What it requires? It requires a future knowledge of reference string, which is not possible. That's why this is not possible, or it is very difficult to implement this optical page replacement. But this page algorithm will give you the minimum number of page fault. Okay, this is the MCQ question. Which page replacement algorithm will give the minimum page fault? So optimal page replacement algorithm will give you minimum page fault, but it is very difficult to implement. Okay, so same string we are using. We will see how it is work. So first three, it is normal because no string is present, so 3 page fault is occur. Now when referring to the fourth frame, referring to the fourth string, which is 2, then to replace with current data, it will check which data or which string is not going to be used for the longest time in future. That means in the page frame we have 701 this data. So it will check which data is not going to be used in the near future. So in this case, it needs to enter 2. 2 is not present. That means out of this 701, one of the data should be replaced, one of the string should be replaced. So it will check in the future which is going to be used. 0 is used. Yes, 0 is going to be used after this 2. So that's why it is not going to replace that 0. Then it will 3. It will check 0. it will check again 4, then it will check 2. 2 is present, so 2 and 0, it is not going to be used for the longest time. Sorry, okay, एक मिनट. Okay, so here 2, it will check 0, 0 is present, then it will check unless and until out of 1 and 7 not getting. So you can check here after 0, 1 is present here, 1 is present here, and after that 7 is here. So 0 and 1, these are going to use in future, and 7 is not going to be used for the longest time. So instead of 7, it will be replaced. Instead of 7, it will be replaced. ओके, तो काय चेक करेल 701 पैकी कोणती स्ट्रिंग ही सगळ्यात लास्टला यूज होईल. मग 0 आधी यूज होतोय, 1 इथे यूज होईल आणि 7 सगळ्यात लास्टला यूज होईल. तर त्या केसमध्ये 7 ला तो रिप्लेस करेल. फ्युचरमध्ये कोणती स्ट्रिंग सगळ्यात लास्टला यूज होईल. ओके, त्यानंतर 0 is already present, no page fault will occur. 3 is not present, page fault will occur, and it will search the string for the replacement. मग त्या केसमध्ये 0 लागणार आहे, लगेच 0 रिप्लेस नाही करणार, आणि त्यानंतर 0 नंतर 2 पण एक लागणार आहे, म्हणजे 1 लॉंगेस्ट टाइम साठी नाही लागणार, तर तो 1 ला रिप्लेस करेल. देन 0 ऑलरेडी प्रेझेंट, 4 साठी चेक करेल 2 लागणार आहे का, नेक्स्टच लागणार आहे त्याला. देन 0 लागणार आहे का, येस, 0 च्या आधी 3 लागणार आहे. सो 2 and 3 he will consider and it will replace 0. So 2, 4, 3 will be contained. Then 2 already present, page fault will not occur. 3 already present, page fault will not occur. 0 not present, page fault will occur. It will search for the string 3 required, after that 2 required. So instead of 4, it will be replaced. Then 3 already present, not occur page fault. 2 page fault not occur, already present. 1 it will check in your future, 2 will be used, 0 will be used. So it will replace this 3 by 1, and so on. And so on. So like this optimal page replacement is using. म्हणजे आपण ह्या केसमध्ये फ्युचर मध्ये बघतोय, फ्युचर मध्ये जी स्ट्रिंग सगळ्यात लास्टला यूज होईल त्या स्ट्रिंगला आपण रिप्लेस करतो. गेटिंग. ह्या केसमध्ये पेज फॉल्ट किती आले, पेज फॉल्ट किती आले, 11 पेज फॉल्ट. ओके, 4 2 6 3 9, सॉरी, 4 plus 2 6 plus 3, only 9 page fault is occur. In FIFO you have seen that in FIFO there are 15 page fault were there, whereas in optimal page only 9 page fault is occur. Okay. So this is the page replacement algorithm which give you optimal minimum page replacement, minimum page fault, sorry, minimum page fault. Clear? समजलं सगळ्यांना? Any doubt? Okay, one more scheme is there. One more scheme is there, that is the least recently used. Okay, one more scheme is there, that is the third page replacement algorithm. So the algorithm is the least recently used. आता ऑप्टिमल मध्ये आपण काय बघितलं तर फ्युचर मध्ये जे लागणार आहेत, जे आपल्याला फ्युचर मध्ये लागणार आहेत लवकरात लवकर त्यांना आपण रिप्लेस करत नाहीये, जे लास्ट लागेल त्याला आपण यूज करतोय. तर त्या रिव्हर्स आहे लिस्ट रिसेंटली यूज मध्ये. ह्याच्यामध्ये काय होतं, रिसेंट पास्ट इज युज्ड ॲज अप्रॉक्सिमेशन टू फ्युचर. या केसमध्ये आपण पास्ट मध्ये चेक करतोय की पास्ट मध्ये सगळ्यात ओल्ड कोण आहे, म्हणजे पास्ट मध्ये सगळ्यात कोणती स्ट्रिंग यूज झाली. फॉर एक्झाम्पल ह्या केसमध्ये 701 इट इज इन्सर्टेड. ज्यावेळेस टू इन्सर्ट करेन, ज्यावेळेस मी टू इन्सर्ट करेन, तर टू इन्सर्ट करताना मी आधी चेक काय करणार की कोणती स्ट्रिंग ही सगळ्यात ओल्ड आहे. 1 जस्ट इन्सर्टेड, 2 त्याच्या आधी सगळ्यात ओल्ड कोणते आहे 7, तर 7 ला मी रिप्लेस करेन. सो कंटिन्यू विल बिकम 201. Next 0 already present, no page fault. 3 not present, so 3 साठी तुम्हाला चेक करावे लागेल. 0 recently used, 2 used, so 1 it is old one, सगळ्यात ओल्ड कुठला आहे 1, so that will be replaced, so 1 will be replaced and 3 will be placed in place of 1. म्हणजे जो सगळ्यात ओल्ड असेल त्याच्या जागी आपण इन्सर्ट करतोय. दॅट इज द लिस्ट रिसेंटली युज्ड. सो द पेज that has not been used for longest period of time, that is chosen as victim for page replacement. Which page? The page which is not been used for longest period of time. Clear? Any doubt? Understood? समजलं सगळ्यांना? Okay, now in the implementation part, it can be used by using the counter and stack. So in the counter variable, it is added in every entry of page table, and whenever page is refreshed, the time is recorded in counter variable. So page with smallest value of counter variable, it indicates that the page refreshed for long time back in past, and that page is chosen as victim. या केसमध्ये आपण काय करतोय, सिंपल एक काउंटर व्हेरिएबल ऍड करतोय आणि जेव्हा जेव्हा ते पेज रेफर होईल त्यावेळेस तो टाइम आपण रेकॉर्ड करतोय. मग जी सगळ्यात स्मॉल व्हॅल्यू असेल, ज्याची सगळ्यात स्मॉल व्हॅल्यू असेल ते इंडिकेट करतं की ते पेज लॉंगेस्ट टाइम मध्ये यूज झाले आणि ते पेज आपण रिप्लेस करणार. And by using the stack, whenever the page is refreshed, it is moved at top of the stack. So stack is manipulated with head and tail. Okay, in the stack model, the page is being refreshed, it is moved at the top of the stack. Okay, that is not part of our syllabus, so that's why it is not that much important. Okay, so just in this lecture you need to understand what is this 3 replacement algorithm. Later part we will discuss in the next lecture. So can I stop here? Any doubt? Okay. Okay, today's attendance I will take that is automatically for automatic, the attendance is generated, from that I will collect the attendance. Okay, so you can do directly now. Lecture is over, you can leave the session. No need to write down your attendance, you can just leave.
Sir,
हाँ बोला.
sir, you have shared me only the notes of the all chapters.
Okay.
That is like type of theory.
Okay.
You haven't shared the PPT of our
So you
chapters.
require PPT?
Ah, sir. Once in the PPT there are clear
Okay,
diagram.
okay, okay. I will share the PPTs. Okay.
Okay,
Yeah.
sir. Not
Okay.
an issue. Yeah,
In
sir.
doubt today's lecture?
Okay. No, sir.
Clear everything?
It was good. I'm confused in optimal page.
Uh,
Optimal page.
okay, okay.
Hello.
हाँ हाँ.
But after that, it means afterwards it's clear because you're confused at the starting. Means you have
Hmm.
explained reverse direction. Then you are
Oh,
again
okay.
corrected.
Okay, okay.
Okay, sir. Thank
Okay.
you.
Yeah, okay.
Okay. I will share my mail with you.
Okay.
Thank you, sir.
Yeah.